Hello, today we're going to look at similar figures and scale factor in relation to area. Now we did a whole chapter on similar figures where we found sides, but now let's look at areas. So there's a really interesting question. How much bigger is this maroon rectangle compared to the black triangle? Well, the sides are twice as big, but is the area twice as big? Hopefully you can look at that and see like this looks a lot bigger than twice as big. So how much bigger? So the scale factor is 2 to 4 or 1 to 2 for all of the sides. And now if we want to see how much bigger the big rectangle is, what we got to do is, uh, well, it's twice as big. That's scale factor. And the perimeter, we can find the perimeters for both of them and the areas for both of them. And you can see the perimeter's twice as big. But the area is much more than that. It's actually 4 times as big. So the scale factor for the area is multiplying by 4. And if you see this, if I put this in there, you can see how 4 things fit in here. So if the scale factor of the sides and perimeters is 2 to 1, the scale factor of areas is 4 to 1. All right, let's do it with another situation, a triangle. If these sides have a 3 to 1 ratio, the scale factor of perimeters, well, it's going to be the same. But the scale factor for the areas, if I put those in, there'll be 9 of those little triangles that fit into this big triangle. So it's 9 to 1. So now what's the relationship between 3 to 1 and 9 to 1? Hopefully you see that that is the scale factor for the sides squared. So the scale factor for the sides is the same as the scale factor for the perimeters. But the scale factor for the sides squared is going to equal the scale factor for the areas. So what does that mean? Now, if we look at this problem, let's look at the scale factor for the sides. 12 is going to match up with 15, so 12 to 15, that's going to go down, divide by 3 on both of them, so the scale factor is 4 to 5 of the sides. If I want to find the scale factor for the perimeter, well, it's the same, so that's going to be 4 to 5. The area, we've got to square it, so that's going to be 16 to 25. Great. Now, if we have the ratio of areas, let's try to find the side. So the ratio of areas, so the area ratio, it's not letting me write. All right, we're back. So the scale factor for the areas is 400 to 64. Now think about, can we reduce anything here? Well, we'll see if, I don't know if that can divide it evenly. I don't think so. So we got to think about something that can divide evenly into both those. I know 8 can divide into both those. And so if 8 divided by 64 divided by 8 is 8, 400 divided by 8 is just going to be 50. Yeah, 50. I wanted to check before you said it out loud, but yeah, of course it's 50. All right, so now I can take those back down 2 more, so 25 to 4. So if that's the ratio to the areas, the ratio of the sides is going to be the square root of that. So the ratio of the sides is 5 to 4. Now we have to think. If the ratio of the sides is 5 to 4, so that's saying big over small is 5 to 4. This one is 40. Now we cross multiply. That's going to be 160 equals 5x. So now if I take 160 divide by 5, that's 32. So this length here is 32 millimeters. Let's try one more. Uh, if I know these two sides that are matching, find the area of this green figure. So the ratio of sides is 6 to 8, which we can write as 3 to 4. So the ratio of the areas is going to be this squared, which is 9 to 16. So if my ratio of the areas is 9 to 16, the smaller one is 13.5. I can cross multiply, and I have 16 times 13.5 divided by uh, 9, and I get x being 24 square feet. All right. Well, hopefully that helps you get through the homework. Good luck.